what is geometry. I'm waiting. Well, in the course of waiting, we know that circle is a shape, actually a plane shape that has no side. So I'll repeat myself. Circle is a plane shape without sides. That means, when I mean side, like a circle does not have, like, let's say this is the shape of a square. You have like this is side, this is another side, this is another side, and this is another side. A circle just have just a single side and is of the angle 360 degrees. That means it is bounded by circumference. So when we are talking about circle geometry, we have to understand what circle is itself. Do you understand that now? So before I move to geometry, let me explain what circle is. Please, can you hear me?
The network is breaking. I can't really hear you clearly.
Oh, I'm sorry about that. I hope it gets better actually. Because I've checked everything. I don't think there's any problem here. Sorry about that. Just hope it gets better. Okay. Though I'm making a recorded version, but I don't know if it will be breaking also like this there. Just try to stay true. Okay. So when we are talking about a circle, this part is known as circumference of a circle. I want to explain the part of a circle because that will guide us through circle geometry. Okay, so in a circle, this is the center of the circle. Let's say we have a line from the center to the circumference. That line is known as the radius.
390.
Hello, what is it? Can you hear me now?
It's still breaking, but I can hear you.
Okay, let's move on. So as I was saying, when we are talking about a circle, I said we have the radius. A radius is a line that pass through from the center to any part of the circle, that means to any circumference of a circle, is known as the radius, while a diameter, as you should know, is a line that passes through from one point of the circumference to another point of the circumference, that is d. So I can say my diameter is equals to 2 times my radius, because from the center to this point is the radius, from the center to this point is also known as the radius. Now looking at this, we also have what we call a sector of a circle. The sector is this point of a circle. It's like a part of a circle, like a pie, like when, like just like your pizza. So this is like the minor sector. The minor sector is a sector with a little angle theta, while the other part with a larger angle, maybe can give it alpha or beta or any form of angle, is known as the what? The major sector. I just hope the stuff is getting clearer. So moving on, we also have what we call the chord of a circle. Like when you have the sector, as I said earlier, this is the sector. Then there's a line like this that moves through the basement of the sector. This line is called the chord of a circle. So this is known as the chord of the circle. Why this down part is known as the segment. Though we are not doing circle mensuration today, but you might need this for some other time. This is called the segment of a circle. So you can say segment is like a sector minus the triangle of a circle. So I'm still looking, is there any other thing we've not mentioned? Okay, I think somehow we've talked about almost everything in a circle. Now what is geometry? Geometry is just talking about shapes and angle. That means, for example, when we are dealing about circle geometry is like we want to get the angle formed by shapes in a circle. For example, you have a shape like this. It can be different type of shape, maybe something like this, and they want to know, okay, what is going to be the angle that this line make in a circle. That's what the circle geometry is. We want to know, okay, what will be the angle that this line make with this circle? What will be the angle that these two lines make with this circumference of a circle? So that is circle geometry. So we'll be considering some laws that guides circle geometry. So I'll try to confirm if you can hear me. So what is the first law of circle geometry? So I'll be starting with the first law rather. So the first law of circle geometry. So the first law of circle geometry tells us that the angle at the center is twice the angle at the circumference. I'll write it here. Angle at the center is twice the angle at the circumference. So thank God I've told you what the center of a circle is and what the circumference of a circle is. Circumference of a circle, for a recap, is the boundary line of a circle. That curvy part, the curvy nature, is actually the circumference. So what they're trying to tell us here is that in a circle such as this, let's say you have something like this. Remember talking about circle geometry. Let's say here is an angle B and here is an angle A. Then it's given as A, this is O, signifying the center, this is B, and maybe this is given as, let's say, Q. So what they're trying to tell us is that the angle at this B is twice the angle at A. So I can say angle AOB, something like this. When you have something like this, it means the angle is at this O. You get at this part, the middle part, is equals to 2 times angle AQB. Do you get now? So the angle at the center is twice the angle at the circumference. Let's say A is equals to 40 degrees. That means angle AOB, which is also B, that's this B I mean here, is equals to 2 times 40 degrees. So I can see my B, which is this here, is equals to what? 80 degrees. So take note of that. That angle at the center is 2 times. That means it's always more than the angle at the circumference. That's the first law. So moving on. Okay, moving on. I'll talk about the second law. Okay, back to the second law. Number 2. It says the angle in a segment are equal. That means angles in the same segment. Let me write it. That's, for instance, you have a circle such as this, and you have something like this. As long I remember I told you about what a segment is. Segment is something like this, like this part is the segment of a circle. It's not compulsory it's facing down, it can face any part. For example, I can have something like this, as long as it has like the same base or the same chord. For instance, these two are dependent on this. The angle here is equals to the angle here. Let's say the angle here is A, they are on this segment, and the angle here is B. I will tell you with all boldness that APB, this is APB, is equals to AQB. QB. That means A is equals to B. As long as they are on the same, look at them, they are touching the same place. Even if you have something like here is P and here is Q, I'll tell you that P is also equals to Q. So we've proved that the angle in the same segment are equal. Try to take note of all these laws. We'll be using them in solving questions very soon. Now moving to the third law. And let me erase my screen. Now on to the third law. The third law says angle of a semicircle is 90 degrees. You have something like this, for instance. Okay, I'll still mention some other things. Now, this is semicircle. A semicircle is half of an angle. For the answer like semi, like for example, if you are playing football, we use the word semi-finals. It means a game to the final. So this is a circle, half of the circle. Some questions will call it the diameter of a circle. That means the angle of the semicircle, the angle facing that center, are you listening, is 90 degrees. Take note of that, very, very important. For example, you have A, this O as usual, and this B. And let's say this P. The O does mostly signify the center, actually. So I can tell you that APB or APB actually is 90 degrees. So we're actually moving to 6 laws that guide circle geometry in Waec. If you can know these 6 laws, I tell you, there's no question you won't be able to solve. Actually, there's no question you will not be able to solve. So we've talked about this. APB is 90 degrees. Now let's talk about the fourth law. Very important. We have a lot of good Waec questions to solve. So moving to the fourth law. The fourth law now says that angles in opposite segments of a cyclic quadrilateral are supplementary. Angles in opposite segments of cyclic quadrilateral are supplementary. Okay, for instance, let's look at this. What is a cyclic quadrilateral actually? A cyclic quadrilateral, from the word cyclic and quadrilateral. Quadrilateral is a four-sided shape. What do I call it? A four-sided shape. That means I can say my rhombus is a quadrilateral. 1, 2, 3, 4. I can say a square is a quadrilateral. I can also say, okay, even my triangle, my rectangle is a quadrilateral. I can see even if I have a parallelogram, I also have a quadrilateral. So when all these things are inscribed in a circle, it is called a cyclic quadrilateral. So for instance, I draw my square inside a circle. As long as, listen carefully, as long as all the four sides can touch the circumference of the circle, it is called a cyclic quadrilateral. Know that. So why I said angles in the opposite segment of the quadrilateral are supplementary. Supplementary actually means they are less than 180. That means if I add this, let's say this is A and this is B, I will have 180 degrees because each of them is less than 180 degrees. So let's just give them name. Let's say, okay, let me change my marker. This is A, B, C, and D. So it means angle ABC, you can also put something like this. Is either you do it this way or you do it this way. Take note of that. So I'm assuming you don't know anything in this. We're all learning this together. Angle ABC plus ADC is equals to 180 degrees. That means if you add both of them, APB is equals to what? A plus B equals 180 degrees. Are you with me now? Okay, let's just quickly do something very, very quick. Okay, something quick. Let's see. Don't mind my drawing actually. It's my pen that is making me sense as if I can't draw. So let's say yes, I would say 80 degrees, and they told you, okay, get this part X, sorry, it's meant to touch this line, and you have A, B, C, D. What does that mean? You have to tell them that, okay, angles in the opposite segment of the circulateral are supplementary. It means ABC plus ADC will give me 180 degrees. So I will say 80 degrees plus X equals to 180 degrees. Do you get that now? So I will now say my X is equals to what? 100 degrees. Now let's move on to the fifth law. The good thing about the fifth law is that it's very similar to the fourth law. That's the very good thing about it. So even indirectly, I can still tell you that we have 5 laws, but let's not just neglect this law. You get now? Don't let us neglect this law. So the fifth law. Okay. The fifth law says the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. Okay, so let me explain this. Let's put it in a diagram format. So I have my circle such as this or something like this. So for instance, okay, let's still use our square. Now, what is an exterior angle? An exterior angle is an angle that does not fall inside the circle, while an interior angle is the angle that falls within the boundary of this circle. So for example, you have an angle outside like this. It's just simple. Exterior means outside, interior means inside. So I have an angle like A here outside the circle. Okay, let's write A, B, C, D, and here we have E. Is always equals to the angle inside. That's the angle that is opposite to it. Can you see it? Okay, maybe let me change my marker. Use it. It is opposite. That means if I want to get A, my A here can also be equals to the A outside here for this photo. That's why I say they are very similar. So the angle here is equals to the angle here. Okay, you might be wondering, how is that possible? It's not so. This and that. So you remember this question. Let's just prove something quickly. Remember this question. We said X is 100 degrees. Now they're not trying to tell me that this 80 is equals to this 80 here. How can I prove that? Do you remember this law in junior secondary school that tells you that angle in a straight line is what? 180 degrees. That means no matter the geometry I will have in a straight line, no matter the number of lines I will have in a straight line, everything there must always be equals to what? 180 degrees. It means if here is 100, this second part should be what? 80 degrees. And can you see that it still follows this law that says the exterior angle is equals to the opposite interior angle. So I hope that's very, very clear. They'll be moving to the sixth and the final law. So some textbooks or some tutors can give you many laws, but I tell you actually that I've taught this topic for several years, and I summarized the whole principle of trigonometry to just these six simple laws. Do you get that now? Just these six simple laws. So now let's move on to the sixth law. Now what does the sixth law say? The sixth law says the angle between a tangent to a circle, you can write that out. The angle between a tangent to a circle and a chord through which the point of contact is equal to the angle in the alternate segment. Let me write that down so we can, in case suppose that are looking at it, the screen visual form, be able to get it. The angle between a tangent to a circle I hope you can see my writing. And a chord. What is a chord? A chord is like a line that passes through one line of the circumference to another part. Listen, you might be asking yourself, okay, is it not the same thing as diameter? There is a difference actually. Look at the difference. I'll draw something now. You should see the difference. This center, right, signify the center. Do you see the difference? Hmm? Now see the difference. This one pass through the center. It is from circumference to circumference actually. Why this pass through the what? It pass through. It does not pass through the center. I mean, so this is a chord. Why this is called what? This is the diameter. Are we cool now? So sorry, I'll rub this off so I can continue my explanation on the sixth law. So after this sixth law, we dive in straight to solving questions. Now I'll come again. The angle between a tangent to a circle and a chord is equal to the angle in the alternate segment. Alternate segment. Okay. So moving on. So what does this mean? Okay, let me draw a circle. So just look at what I'm going to do here. Let's say I have a line such as this. Okay, another line. Another line right from here straight down to here. So we have another line here. Are you with me? Okay, so we have something like let's see, we have something like a tangent. Sorry, I know I did not tell you what a tangent is. Okay, let's draw something. Okay, let's say I have a tangent. Sorry about that. Now, this is a tangent. A tangent is a line that passes through the circumference of a circle. If I have a line that goes through this way, it's called a tangent. Any form, as long as it can pass through the circumference of a circle is a tangent. The line itself is a tangent. It will not enter. There's a mistake here. This went through actually, which is not right. Is meant to just pass through the circumference like this. So for instance, we are told that the angle between a tangent to a circle and a chord, that means there's an angle between the chord. This is like a chord actually. It does not pass through the center. Sorry, it might look as if it's passing through the center. This is a chord, and this is the what? Tangent. A is equals to the alternate segment. What is the segment? Have you noticed that we call all these things segments? Segments are just is a point or is the angle between the polygon, the geometry itself inside the circle. So what is the opposite angle to this place? It is what? It is this angle. So I can say, okay, let me give my something names. Okay. So this is what we call tangent TE. Most time they might write it this way in your exam, tangent TE. So I can say my BAP, are you with me, is equals to my what? PBE. That's PBE. Because of what? The angle between a tangent to a circle and a chord is equals to the what? Angle in the alternate segment. Don't worry if you don't get all these things perfectly well. The thing is that for you to even reach this stage, you've tried actually, because we'll be solving a lot of questions very very soon, actually right now, on this. So expect our questions right now.